A very warm good morning to all our viewers. I welcome you all to the fourth and the final session of DSC ML Talks event. I am Aman Sharma, the ML leader DSC VIT Bhopal, and we have here among us the entire DSC ML team, Ayush Mishra, Indushish Paul, and Yash Sinha. This is the final session for the DSC ML Talks event. Throughout the month, we conducted several hands-on machine learning workshops where we covered all the basics and the prerequisites of machine learning aimed at getting you started in the field of ML. This is a final session and it's going to be a hands-on workshop on regression and classification modeling using Scikit-Learn. First, we'll be understanding what exactly regression and classification is, followed by a hands-on workshop where you will see how we can create our first machine learning models. So, without any further ado, let's kick off our event. We'll begin with Indushish giving you a short introduction to regression. Indushish, over to you.
Thanks a lot, Aman, for the great introduction. So, without wasting any further time, I'll start with today's first topic, regression, specifically linear regression. So, before starting linear regression, let's understand a bit about what a regression is. I guess you guys all already know about supervised learning from the first session, where Aman gave us a very good description of what supervised learning is. Regression is a branch of supervised learning. Now, even though linear regression is a very famous algorithm, before jumping onto the linear regression, let's first understand what regression actually means, because regression analysis is a very useful tool in statistics. So, a regression problem is when the output or the target variable in a given problem is real or a continuous value. For instance, if we have the age of a person or the price of an item as the output variable. Now, let's suppose we have an input variable, x and an output variable y. Now, x is our feature, y is our target variable. We need to predict the value of y using x. So we'll map our x, the input variable, to a function f, and f of x will be our predicted variable that will denote as y hat. Now y hat is our predicted value, y is the actual value. In a regression, what we do is we compute our y hat and then afterwards we compare it to the actual y. This is what happens in regression. We compute y hat by mapping our input variable to a function. Now, what exactly linear regression is? Linear regression is the simplest of the regression algorithms out there. Here, the f of x will be a simple linear function. For example, y hat will be equal to b0 plus b1 dot x, where b0 is a constant, b1 is also a constant associated with x. Now, doesn't this equation looks familiar? Obviously, it is an equation of a line where b0 represents the y-intercept and b1 represents the slope. Now, let's take an example to understand what is happening. Let's consider a scenario where you need to lose weight. Let's also consider that there's a connection between how many calories you take in and how much you weigh. So here the amount of calories you take in will be your x, and how much you weigh will be your y. So here what we do is we take in the calories and we use the calories to calculate b0 and b1 so that we can predict our weight. Here by using this type of regression analysis, you can understand the relationship between calories and how much you weigh. Furthermore, let's take another example. Let's say that you have been gaining weight over the last few years. Now you want to predict how much you weigh in the next 10 years based on your calorie intake. If the calorie intake remains same, now regression analysis through this can help you predict that. How? Because you will be able to compute b0 and b1, and from that you'll be able to obtain y hat, that is your predicted value. To be specific, This is the goal of linear regression, to generate or to understand the relationship between the input variable and the output variable, or in a more graphical manner, to generate a trend line based on the data you have gathered. Here, please note that only the best fit line is considered because the error will be minimum between the predicted and the actual values. Now let's try to visualize what we just saw here. Let's take an example. Let's consider the blue dots as your data points. They are mapped in a graph such that your x-axis is your input and y-axis is the target variable. Now the blue dots are scattered in a linear fashion, right? So what will happen is we'll try to compute B0 and B1 from using these blue dots, and what happens is that we uh, compute the minimum error, the B1 B0 and B1, which gives us the minimum error after we get the predicted value. And the red line that you see here is the regression line that we gain after plotting x and y hat. So this is what linear regression is. In linear regression, basically, we take the data points and generate a trend line to further understand or to explain the relationship between the input variable and the output variable. Now, I'm sure you guys already know that we need to install some libraries in order to conduct these experiments. So Scikit-Learn will be our primary module for that. And again, if you want to install the latest official release of Scikit-Learn, you need to use pip install Scikit-Learn in the same manner that I have written here. So that was all about linear regression. Let's get started with some hands-on experience in Google Collab. Ayush will guide you through it.
So hello everyone, we'll be seeing the hands-on tutorial of linear regression. So first of all, we'll be importing all the required libraries that are pandas, numpy, matplotlib, and cbond. So first of all, we'll import our dataset from the pd.read CSV function. The dataset is usahousing.csv. So first of all, we'll do some exploratory data analysis. So we will first of all print the df.head, that is the first 5 rows of our data set. So we can see the columns are average area income, average area house age, average area number of rooms, average area number of bedrooms, area population, price, and address. So here we will be trying to predict the price of the house from these other columns. So for that, we'll have to see if there are any null columns or rows. So using df.info, we can see the column wise information, and we can see that there are 5,000 non-null rows in each of the column. So it is perfect for our usage. So we will just use df.describe to see few mathematical functions like count, mean, and standard deviation for our data. Now we will see the disk plot for our column price. So we can see that from sns.diskplot df price, most of the price is around 1.2 into 10 raised to power 6. Now we will see the correlation heat map of our data set. So the correlation value ranges between -1 to 1. A positive correlation coefficient of 1 denotes a strongly directly proportional relationship between a pair of variables. On the other hand, a correlation coefficient of -1 denotes a strong inversely proportional relationship between the two variables. And when it is 0, that means they have zero dependency on each other. So we will draw first a heat map, sns.heatmap df.core, and from df.core price, we will see the correlation of other columns with the price column. So you can see that average area income is highly correlated with a correlation factor of 0.639. Then even average area house age has a correlation factor of 0.45, and the area population has a correlation factor of 0.4. So we will be using these three columns: average area income, average area house, and area population for predicting the price of the house. So for that, we are splitting our data into features and targets, where x is equal to features and y is equal to target. So in x, we are taking the columns average area income, average area house, and area population. And for prediction or target the y, it is price. So first of all, from Scikit-Learn.model selection, we will import the train test split. Then break our data into training set and testing set from the train test split function. With a test size of 0.2, that means 80% of the data will be used for training and 20% of the data will be used for testing. So now from Scikit-Learn.linear model, we will import linear regression, which we are going to use. Now model is equal to linear regression. So our model is created. Now model.fit x train comma y train. So we will be fitting our model on the training data set. So as we have trained our model, we will just print the coefficients and the intercept. So as shown by Indrashish, the B1 will be 2.16, then B2 will be 1.6 into 10 raised to power 5, and B3 will be 1.5 into 10 raised to power 1. And the intercept, that is B0, will be minus 1796867. So now we will create a new variable y hat, which will be the prediction of the model on the test data set. So y hat is equal to model.predict of x test. So now we'll create a regression plot between the y hat and the y test. So you can see the red line is the y hat, which has been predicted by our model, and these small dots are the y test, which are the different points in our data set. So we can see the line fits quite accurately here. And finally, we will just see some metrics to and with all the various accuracy measures. So for that, we'll import metrics from sklearn. Then we will print the mean absolute error from metrics.mean absolute error y test comma y hat. Then we will print the mean squared error, root mean squared error, and R2 square. So for all these, we can see that R2 score is around 0.78. So that means our model has fitted quite well and it's working fine. So that was all, and I will hand over to Indrashish.
Guys, so now we'll move on to the fun part of this session. We'll be organizing a quick quiz on regression, and you need to answer fast because the lucky winner will be getting a cool DSC swag. And I'm dropping the link for the quiz in the chat. You'll have exactly 3 minutes to attempt the quiz, and after that, the time will be up. So the link has been dropped in the chat, and your time starts now. Go ahead and attempt the quiz. Best of luck. Just 2 more minutes left, guys. final minute, be quick, and the responses has already started pouring in, so I need you to be quick if you want to win the swag. Okay guys, so the time is up and we won't be accepting any more responses now. So no worries if your score was not that good in this quiz. We'll be having one more quiz at the end of the session. So best of luck for that one and stay tuned if you want to have one more chance to earn a swag. So with this, we move on to the second half of this session. Indrashish will be giving you a quick introduction to what classification is in terms of machine learning terminology. Now over to you, Indrashish.
So I'll get started with classification and, to be more specific, logistic regression. So before we get further ahead into logistic regression, let's understand what classification is and how does it help in machine learning. So classification is an important category of supervised learning problems where the output or the target variable, in contrast to regression, is a categorical or a discrete value. For instance, if you have a problem statement like if you need to predict if an email statement is spam or not, so your target variable will be spam or not spam. This is what a classification problem is. Same is it with another problem. For example, if you are obese or not. So the target variable will be obese or not obese. So this is what a classification problem is. Since it's a supervised problem, we'll have the same equation as previous. Y hat equals f of x, where f will be a function. Now it will depend on various algorithms what this function will be. In our previous case of linear regression, we had a linear function. In this case too, we'll have a specific function, but we don't require the value obtained from the function. We don't require the y hat obtained from f of x. Instead, what we do is calculate the probability of occurrence of the concerned categories from this equation in order to correctly predict which category will the test variable will fall onto. To be more specific, in case of logistic regression, what happens is, in order to calculate the probability, we first use the same equation as we did in linear regression. We have a linear function here. We have a linear function that is mapped to y hat. But since y hat isn't the final result that we need, we further map it to a sigmoid function, also called as logistic function. Now, how does the sigmoid? This is how the sigmoid function is written as 1 by 1 plus e to the power minus y hat if we have sigmoid of y hat. So this gives us the predicted probability or the computed probability, because the hypothesis of sigmoid function limits the result between 0 and 1. So this gives us the probability of occurrence of a specific class. Now, for instance, in a binary classification problem, if we have our target variable as 0 and 1, so having a probability of greater than 0.5 will mean that the predicted class or the predicted category will be 1. And if the probability is less than 0.5, that will mean that the predicted class is 0. This is how logistic regression works. Now, since our calculated y hat will be further mapped to a sigmoid function, or also called as logistic function, this technique is called logistic regression. But please note that it is a regression technique because we have a linear function associated with it. Here again, we also generate a trend curve instead of a line based on the data that we have gathered. We also have the best fit curve in order to have the minimum error between the predicted and actual values. But it is a regression technique. It is obviously a regression technique, but it is used for classification because we map it to binary classification outputs. That is the reason it is used for classification. Now let's try to visualize it. Let's say we have two categories, as I explained before, 0 and 1 mapped into the y-axis and our input variables in the x-axis. So the green dots will represent the data points that we have. Now if you try to fit a linear regression line, this is how it will look. But try to understand it intuitively. Our result lies between 0 and 1. So will there be any chance of extending it after 1 or below 0? That cannot be possible, right? How the linear regression does. So it's like this portion. This portion is not viable along with this portion too. So in order to correct this process, there is another regression technique that we introduced just now, that is logistic regression. And here what we do is limit the value that is above 1 and less than 0 below it to 0 and 1 only. This will result in a S curve, that is the curve generated by the sigmoid function. Now please get that the predicted values from the S curve is not your final answer. These are the probabilities that you get from the graph. And afterwards, you need to map these probabilities just like the previous one I mentioned. For example, if we have the probability more than 0.5, the predicted class will be 1. And if it is less than 0.5, the predicted class will be 0. So here again, the red line in the logistic regression curve, the red curve you get is our sigmoid function. This is how logistic regression works. Here again, in order to use logistic regression, you would need to install Scikit-Learn. And let's get started with some hands-on experience on logistic regression using Google Colab.
All right, everyone. Good morning. So right now we'll be taking a look at hands-on walkthrough of logistic regression. So I'll just quickly share my screen. All right. So first of all, thank you, Indrashish and Yash, for giving us information about linear regression and how things work, and also telling us about what is classification and how we can use logistic regression for this problem. So in this notebook, we will be walking through a code for logistic regression, and we'll be performing all the steps necessary, like the steps that we perform before modeling, as well as how we check how good our model is. So let's quickly get started. Before starting, I would just like to say that all of this code that you see for DSC ML Talks is available in the GitHub repository. So feel free to go and check it out from there. All the resources are for you. So feel free to download them, run on your own Collab, and check out for yourself. And after every notebook, we have a task for you. So make sure you're performing those tasks as well, as it is a great learning method. All right, so moving on with logistic regression. So in one of our EDA sessions, that is the exploratory data analysis sessions, we saw a data set on Titanic, or the famous Titanic data set. So we'll be using the same here. And let me just give you guys a quick recap. So these were the columns that we had over here that you can see. So we had passenger class, that is P class. It determines the class in which the passengers were traveling. So we have three classes in total, that is the first class, second class, and third class. The name of the passenger, the gender of the passenger, the passenger IDs, survived, which means whether the passenger had survived the accident or not, the age of the passenger, whether they had a sibling or spouse on board, whether they had any parents or children on board, the ticket ID, the price of the ticket, the cabin, and embarked, which was the place that they were traveling to. So our goal is to predict whether, like, our goal here is to predict whether a person would survive this accident or not. All right. So the very first thing that we do is we import all our libraries. So we'll be using NumPy, Pandas, Matplotlib, and Seaborn. NumPy and Pandas are for all the mathematical work and for working with the data frames that we have or the data in general. And Matplotlib and Seaborn are used for visualizing the data that we have in hand. So the very first thing is that we will read the CSV file that we have of our data that is stored here over in the content as Titanic train.csv. As you can see, you know how to import your own dataset into Drive. You just go here, click on import, and you will be able to see you will be able to import your own dataset. Now we will call the head on our data frame, that is df. It shows the top 5 rows of our columns. As you can see, we have all these columns over here. We can see embarked, we can see cabin, fare, ticket, page, that is parents or child on board, siblings or spouse, SIV-SP, that is siblings or spouse on board, the age of the passenger, the gender, name, passenger class, survived, whether they survived or not, and passenger ID. Moving on, we call describe on it so that we have a better overlook of the whole data set that we have. So it will tell us about mean of each column, the standard deviation that we need, what is the maximum value present in a particular column, and so on. It is always good to use df.describe because in many cases this helps you in filling up the nan values that you might have in your dataset. So as I discussed earlier in the last few sessions, that you will never get a dataset that is without nan values. So there will be nan values in your dataset. In most of your datasets that you work, the real world datasets. So this can help you in filling up those nan values. All right, so the next thing is that we check for nan values in our data set. For that, we will be using a heat map that we just saw in the linear regression notebook. So what we are doing is we are creating a heat map for all the null values present in our data. So as you can see, the age column has a few null values and Kevin on the other hand has a lot of null values. So let's see if we can do something about it, or do we just drop these columns as these are not very important to us. So this is the thing that we talked about earlier as well. So in your data set, you will have multiple columns. In this data set, you don't have many columns, but there will be data sets where you have 50 to 60 columns, and they might have many nan values. Now, it's completely up to you whether you want to keep these columns or you want to drop them. Now, when it comes to dropping, some of these columns may be very essential for your model or will be an important feature for your model, so you just cannot drop it. So in that case, you have to impute or fill these nan values that you have. So in this case as well, we will be filling up some of these nan values, and then we'll see what we can do with the rest of them. Once again, we are calling the heat map and checking the correlation of each column with every other column over here. So as you can see, this shows the values that we for correlation, and we just discussed in the linear regression what is a positive correlation, what is a negative correlation, and so on. So make sure you go through that notebook once again so that you have a better idea, overall idea of this. All right, and these values are from -1 to 1, so that's why you are seeing some negative values as well over here. Now the next step is going on to data pre-processing. Now, as we saw in the above table, that we have some nan values, but when we consider k-bin, let's just go quickly and see the k-bin column over here. So this is the k-bin column, and it has this C85, C123. So we know that these are the k-bin numbers that the passengers are living in. Now, if we come and see the heat map that we created, we can see there are too many nan values over here. Now, either we can fill all these nan values with a similar value or mean or average of it, but as it is not a numerical data, so it will be a lot of work over there, and I don't think K-bin will be an essential feature for us or is needed at all for modeling. So we'll just go and drop the K-bin over here. and we'll just we'll drop the Kevin over here, and then we'll just call the head. And wait, when I run this, and when I run this, you should not see any Kevin. So as you can see, we just dropped the Kevin from using df.drop that we had seen during the panda session. So we dropped the Kevin, and we have the rest of the data frame with us. All right, so let's just go and visualize a little bit of the data that we have. So the very first thing that we'll be doing is we'll be using a count plot to visualize how many people survived. So as you can see, we have the values over here. So all right, so we have the survivor counts that we have. So how many were able to survive, and how many were not able to survive the accident. Then we are going on and checking. We are checking the same thing, the same columns that are survived data, but we are also adding a hue that is the gender. So based upon the genders, we are determining how many were able to survive and how many were not able to survive the accident. Then we are using some bar plots just to check the same thing once again, but how many based upon the gender only. Then we are calling a mean on the P class, and we are also calling survive. We are calling group by P class dot survive dot mean. So that means that we are grouping the data based on the P class, and then we are calling dot survived on it. So which means we are trying to find how many survived from each passenger class, and then we are calling the mean of the data. So these are the values that we have over here. Then we'll check from each class how many were able to survive the accident. So as you can see, the maximum were from the first class, then the second class, and the least were from the third class. And we call the count plot to check how many were able, how many survived, and how many did not, and from each particular class. So this is P class 1, P class 2, and P class 3. So we can see from all of these plots that maximum number of people that died were from third class, and yeah, it somewhat makes sense also because P class was the cheapest class that was available on the ship at that moment. So most of the passengers were traveling from the third class was the cheapest class that we had, or the cheapest ticket that we had on the ship. So most of the people could afford that and were traveling in that. And then there must be a great difference in P class in the passenger class 1 and 2 and 3. So maybe they were on the lower side of the ship, and that is why we have more number of people from third class dying. All right, so we also had nan values in our age columns. Now I'll just quickly go up to the heat map that we had. So as you can see, we have a lot of nan values, but as compared to the cabin, we don't have many. So we can actually go and fill these up. We also call the describe, so we are aware of the mean age of the people and mean age of the people that we have in our data, and the mean of the P class as well. So what we are doing is we are creating a function impute, which is filling up these age values based upon their P class. So what we know from our analysis is that the people that were traveling in P class 3 were actually younger, very, very much younger as compared to those who are traveling in passenger class 1 or 2. So what we have done is, if the P class is 1, then we are filling up the nan value for age as 37. If the P class is 2, then we are filling it up with 28. And finally, if it is not P class 1 or 2, then we are filling it with 24. Otherwise, we are just keeping the age as it was. Let's quickly run this, and then let's impute the data that we have. Now, if we go ahead and check df.isNull.sum, so what we are doing is we are checking the total count of null values in all of the columns. So as you can see, we just have 2 remaining null values, and in age we have 0 null values, which means we filled up all of those nan values that we had using these ages that we just created in impute function, and which is what we are applying to these 2 columns as well. So we are changing the age value of the age with regards to the age, the P class, and then we're applying the function that we created. So it automatically gets applied, and all of these nan values are filled with the values that we want. All right. So we have done a lot of stuff till now. Now the next step that we will be doing is converting some of the categorical values into the numerical values that we need. So if you go to the main data frame that we have. So as you can see in the column sex, we have male and female. Similarly, for embarked, we have S, C. So these are all categorical values, and we need for them. These actually work as an important feature for our model. So we need them in a numerical value so that we can feed it to the model. So what we are doing is we are calling p.getDummies upon the sex column and also on the embark column. So what is happening is that we are taking the values, the categorical values that are present, and we are converting them into different separate columns themselves, and then they include numerical values. So if you are converting the sex column into if you are calling p.getDummies on sex column, then it creates two columns, that is the male and the female, and then if the person was male, it gives 1, otherwise it's 0. So, and we are also calling drop first equal to true. So what it does is basically it drops the first column that we have. So in our case, we had in sex we had only two categories, that is the male and the female. So if you drop female, it automatically if you drop female, we don't need to actually use it in our data. So just one column of male is all right, because if it is 1, it means it is male, and if it is 0, that means it's not male, which automatically implies that it's a female. Similarly, we are doing this for embarked as well. I'll just quickly run this cell. And for embarked column as well, we are doing the same things. And I think we have 3 categories over there, that is C, S, and Q. So we are carrying out the same procedure for that as well. And we can just quickly go ahead and see how these look. So this is for the sex column, and this is for the embarked column. So as you can see, we only have 2 over here, and we only have 1 column over here. Now, as we have them, we'll just put them together in one data frame, that is df1, that is equal to p.concat. So what we are doing is we are concatenating the main data frame that we had along with these newly formed data frames that we just created. And when you check the head, you'll be able to see that you are still able to see these sex columns and embark column, but you're also able to see male, Q, and S, which determines the gender and the places that they're traveling to. All right. So what we are doing now is we are dropping some of the columns that we won't need. So in our case, we won't need sex because we already have male over here. We won't need embarked as well because we have already converted these values. We don't need name necessary, and also we don't need this ticket ID or ticket number. So we'll just go ahead and drop all of these from a data frame. And when we check head of a new data frame, we only have these columns which are important and which are actually needed for making our whole model. Now the fun part, or the very last part of the notebook, is creating the model. So we have our data frame over here. Now all we need to do is just create the model. So for that, we are using the Scikit-Learn that we imported using pip install, or if you're using Conda, we have Conda install for that. So from sklearn.model selection, we are importing train test split. From sklearn.linear model, we are importing logistic regression, and sklearn.metrics, we are importing classification report and confusion matrix. All right, cool. So now we have our libraries, and so now we have libraries imported, and the next step is that we'll define the features and our target. So the features are, what I'm doing is a df1.drop survived. So what I'm doing is survived is actually our target. So what we are doing is we are just dropping it off and selecting all the other columns as our features, and then we are just giving df1.survived, which is our target that we need to predict. So once you have done that, we can go ahead and split our data set using the train test split. Now, why we exactly do train test split is because we don't want to train our data completely on the whole data set that we have. So we just take 70% of the data to train it, and the rest 30% is for testing it, so that a model is able, when we evaluate the model, it gives us a better result, and like it actually works. It works on a data that it has never seen before, which is what we want. So LR is equal to logistic regression. It creates an object of the logistic regression class, and what we are doing is we are fitting the training data like we did in linear regression as well. We are fitting the data to the logistic regression model, and then we are calling LR.predict on the test data that we have. And finally, we will be printing out all of our test results and matrix and confusion matrix and all. So very first thing now, very important thing that we want to understand is how do we evaluate these models. Now for linear regression, you have other things like other stuff to metrics to evaluate a model on as compared to logistic regression. So in linear regression, you can use the RMSE or root mean square error, or MSE, that is the mean square error, or mean absolute error, to check how good your model is, the accuracy. But in terms of classification approach, the approach of using the mean square error or using the accuracy to determine how good your model is not exactly the way to go. So what we're doing is we check, when we talk about classification problems, we check for precision, recall, and F1 score, right? So I'll just explain why we do so. So when we are using, suppose if we let me just say that if we use accuracy as a measure for evaluating the model, then there can be a chance where there can be a chance where if we have a small number of obviously a very small number of positive classes compared to the total class. So the basic definition of accuracy is that the number of samples, it is basically the number of samples predicted correctly upon total number of samples. So it might happen in some cases that the accuracy might be showing as 99% because of how the data is and how it predicted the correct classes. But in the real case, the F1 score, the precision and recall might be very low, which just shows that the accuracy is not the measure to go with when we are talking about classification problems. So let's just understand what precision, recall, and F1 scores are. So I have drawn the confusion matrix over here, which will be important for you to go through. So what we are doing is these are, we know we have true positives, false negatives, false positives, and true negatives. So TP, FP, FN, and TN. So let me just let's just understand this as let's take a case where we are trying to classify shoes brands, and we need to classify whether a shoe is a Nike or not. So when you talk about precision, so we'll say that out of the total shoes that we have classified, how many of them are actually Nike? So in the real definition, it tells us when we predict something as positive, how many times we were correctly we were actually positive while predicting that. So this is what precision is, and the precision is nothing but true positive upon true positive plus false positive. So similarly, we have recall for that. So when we're talking about the shoe classification, so it is out of the shoes that are actually Nike, how many are classified as Nike? So out of total shoes that were actually Nike, how many of them we were able to classify as Nike? So recall basically tells us that out of actual positive data, how many times we predicted correctly. So formula for that is that total positive upon total positive, true positive upon true positive plus false negative. And similarly, we have F1 score, which is the weighted average of precision and recall. The best value that we can have is 1, and the worst value that we can have is 0. So F1 score is nothing but 2 into precision into recall upon precision plus recall. So these are the metrics that you need to know when you are working on any classification problems, and these are the metrics that you should go with when you're working on classification problems. So with this, we come to an end to this book. At the end of the book, there is a small task for you that we performed earlier on different columns, but for you guys, we have a different column over here. So yeah, that's pretty much it when it comes to logistic regression. And once again, all of these notebooks will be available on GitHub. Let me just quickly recap what we did over here. So we first imported our data set using pandas. Then we did some work on it by checking for the null values, by checking the mean of different columns, the average of different columns. Then we imputed these null values that we had using the already existing columns that we had. Then we converted the categorical values into numerical values, which in the end we fed to our model. And then we evaluated how the model performed. And yeah, that was pretty much it. And with this, we come to an end to the logistic regression notebook, and I think we can go ahead with the quiz now.
Okay guys, so we'll be doing the final quiz for this session. I'll be dropping the link in the chat, and once again, you'll have only 2 minutes to attempt the quiz. So the link is available now. Go ahead and attempt the quiz. Best of luck. Remember, the fastest one to answer all the questions correct or maybe get the highest score will be the winner and they'll be getting the swag. So be quick. The time starts now. Just 1 more minute left. Okay guys, so the time's up for the quiz now. The winners for both this session's quiz as well as the previous session's quiz will be announced in a joint announcement very soon. And the link for the OD as well as for the submission has been dropped in the chat, as well as all the resources for the ML Talks events. The link for that one has also been dropped in the chat. So make sure that you fill that OD plus submission form before midnight today. And I guess with this we come to an end of our month-long ML Talks event. And we really hope that you got to learn something from this event, at least enough to get you started in the field of machine learning. See, machine learning is all about exploring, experimenting, and learning. So just keep doing that. The notebooks that we have used for today's session, they have some exercises like Ayush and Yash mentioned earlier. So make sure you attempt those exercises and try to get a better gist of what we learned today. It will help you practice everything and you will get a better understanding once you are done with the exercises. So in case you have any doubts, you can ask them on the Discord server or maybe even DM us if you want. And with this, we come to an end of our session. So link for everything is available in the chat. If you have any doubts, you can ask them now. I guess we can end the session now.